So good afternoon to all. So this is Selkumar from SNS College of Technology and Department of Computer Engineering. So now I'm going to tell about what is CPU scheduling and algorithm evaluation. So what is algorithm evaluation? So the first problem is defining the criteria to be used in selecting an algorithm. So it is a very important category to algorithm evaluation. So criteria are often defined in terms of CPU utilization and response time or throughput. To select an algorithm, so we must first define the relative importance of these elements. So our criteria may include several measures such as maximizing CPU utilization and maximizing throughput. So the maximum CPU utilization means, so under the constraint that the maximum response time is 1 second. So maximizing throughput means such that the turnaround time is linearly proportional to the total execution time. For total execution time means so one process need to complete some particular time. So this is the total time taken for completing the one process, that is called the total execution time. So once the selection is criteria have been defined, so we want to evaluate the algorithms under consideration. So analytical evaluation. So one major class of evaluation method is analytical evaluation. So the analytical evaluation means that it uses the given algorithm and the system workload to produce a formula or a number to evaluate the performance of the algorithm for that workload. One is deterministic modeling. So deterministic modeling is one type of analytical evaluation. So these deterministic modeling methods takes a particular predetermined workload and defines the performance of each algorithm for that workload. So deterministic modeling is a simple and fast algorithm evaluation model. So and also it gives as exact numbers of an exact number of algorithms to compare and allowing use to compare the algorithms. So however it requires exact number for input and it is answers apply only those cases. So this is a deterministic modeling. For example, assume that so we have the workload is shown below. So all 5 processes arrives at time 0. So in this order given with the length of the CPU. So but the given millisecond is 0. So process we have P1, P2, P3, P4, P5 and the burst time 10, 20, 3, 7, 12. So consider that the first come first served SJF and round robin is a quantum equal to 10 millisecond. So scheduling algorithms for these set of process, which algorithms would give the minimum average waiting time. For these first come first serve algorithm, so first come which one is first with the first come one first serve the and then terminate the algorithm. So we have P1 is first time, so 0 is initial time, so we have 10 process time. So next one P2, so we P2 have millisecond and P2 have a 30 P2 have a 39 millisecond for process and total 39. So P3 have a 42 milliseconds and P4 have a 42 millisecond for process P4 and 49 millisecond for process P5. So thus the average waiting time is 0 plus 10 plus 39 plus 42 plus 49 divided by 5 equal to 28 millisecond. So these are the 28 in the first come first served millisecond average waiting time. So with the non-preemptive SJF scheduling, so we execute the process. So non-preemptive means we have a shortest any shortest process come under previous execution, we have to stop and give the CPU to the shortest process. So the waiting time is 10 milliseconds for process P1 and 32 milliseconds for process P2 and 0 millisecond for process P3 and 3 milliseconds for process P4 and 20 milliseconds for process P5. So thus the average waiting time is 10 plus 32 plus 0 plus 3 plus 20 divided by 5 equal to 13 milliseconds. With the round robin algorithm, with execute the process are P1, P2, P3, P4, P5, P2, P2, P5, we have to complete with the minimum shortest time of article time. So the waiting time is 0 millisecond for process P1 and 32 millisecond for process P2 and 20 milliseconds for process P3 and 23 milliseconds for process P4 and 40 milliseconds for process P5. So thus the average waiting time is 0 plus 32 plus 20 plus 23 plus 40 divided by 5 equal to 23 milliseconds. So we can see that in this case the average waiting time obtained with the shortest of first policy is less than half that obtained with the first come first served. So the round robin algorithm given as an intermediate value. So SJB policy will always result in the minimum waiting time. Second one, queuing models. So this distribution of CPU and input burst. So this distribution can be measured and then approximated or simply estimated. So the result is a mathematical formula describing in the probability of particular CPU burst. Commonly this distribution is exponential and described by its mean. So possible to compute the average throughput and utilization and waiting time and so on the for more algorithms. So the computer system is described as a network of server. So each server has a queue of waiting process. So the CPU is a server with its ready queue and its input on system device queue. So this area of study is called the queuing network analysis. So the example is average queue length algorithm and n equal to lambda into w. So a new process will arrive in the queue. So if the system is in the steady state and the process number of process leaving the queue, so must be equal to the number of process that average this. So in this known as a Little's formulas is a particularly useful because valid for any scheduling machine and arrival distribution. Thank you.